Hello everyone. In this session we will understand clustering in unsupervised learning. Actually the thing is I need this topic in the very early for this chapter, but I haven't created this content. Um, Based on clustering we're going to understand hierarchical clustering techniques. Okay, so I had given you some idea on what is clustering and stuff, but in this session we will elaborate it in a more defined way. Okay, so you already know that it is a technique that groups similar point in the same group. Okay, so it groups similar points in the same group. So if this is the graph, then let's say these are the green points. This is going to be my first cluster because they have the same identical or the similar characteristic data points. This is my second cluster because they are possessing the similar characteristic, and that's why I had put them in the cluster in the different clusters. Okay, so this is my hashtag cluster 2, and let me take another color to have one more cluster. So this is the cluster for 3. So this is my hashtag C3 cluster. Okay, so I have 3 clusters over here, and the data points that resides in the cluster are having similar characteristic, and that's why I had put them in the same group. So this is clustering. Now what is the difference? The group of similar points, so I'll also write it down here. The group of similar data points, the group of similar data points is called cluster. Okay, so if I'm talking about one cluster, then the group of similar data point is clustering, and clustering is whole of a thing. Okay, now the next thing is, what is the difference between clustering and classification slash regression model? What is the difference? So when I say difference between clustering, and clustering is unsupervised learning technique, right? Clustering and let's say classification. Actually it should be slash, but let me just down it in the denominator. So classification denominator regression model. Okay, so what is the difference here? Now one thing I already told you about uh, clustering in the very first lecture of unsupervised learning, that um, we have a different data set for unsupervised and supervised learning. Okay, I told you about that. So remember that this clustering is an unsupervised learning technique. I think you know that this is unsupervised learning technique, and this particular thing is classification regression, is basically a supervised learning technique, right? This is what you know. So when I say classification, in classification and regression model, in classification and regression model, we are given some data set. So let's say my data set is, I am representing my whole data set with the help of this D, capital letter D. So this is the data set which contains the data, contains here, I'm writing it down here, contains data. So I have a data set representing with this capital letter D, and have a data points in the form of x of I. So this is the data point x of I, and class label in the form of y of I, right? So my data set consists of x of I and y of I. In the data set, here. This is my x1, x2, and let's say this is my y. And I hope you can understand it, that this bunch of thing is x of I, and this is y of I. This is my class label, and these are the data points. And certainly these data points I can plot it in the scatter function, the comparison between x and y. Okay, I can do that. Now this y of I here, this class label, for specifically for the classification, where my pointer is, actually it points to somewhere, yeah, here. So this y of I basically here, from the classification regression model, this y of I belongs to, so here it belongs to, this sign stands for belongs to, it could be 0 and 1 for classification. This is binary classification, right? And or it could be like 0, 1 till n. For this is for binary classification, and this is for multi classification. So multi classification, when you are having like five class labels, and among the 5 class label you want one. Okay, so this is multi classification, and this is the binary classification. Okay, so your y of I belongs to the classification model, which is this, or it also belongs to some real values for regression model, real values for regression model, and this is for classification model. Okay, these are the two output of y of I. So in with respect to classification / regression model, if you are having class label yi, then it will give you real values for regression model and classification for classification model. Okay, however, when this specifically is for supervised learning, but when we are dealing with unsupervised learning, so what I'm going to write it down here is how it becomes this. So when comes to clustering, we provide a data set D. Again, this is a data set. We provide a data set D that only contains, I hope you remember this, only contains data points, x of I, and we don't have any class label y of I. Okay, so we have only data points x of I, and we don't have any class label y of I, right? This is the unsupervised learning, or I can say clustering. So based on this clustering, we're going to understand hierarchical clustering technique, and they are the most popular and easy to understand clustering techniques, and they are of two types. One is agglomerative technique, and another one is divisive technique. So let's understand these two techniques for hierarchical clustering. Okay, so I'll say the topic name is hierarchical clustering technique one is agglomerative technique and another one is divisive technique. Okay, so these are the two techniques that we will understand. So when I say, so when we are dealing with agglomerative, so let's first understand this agglomerative technique. So this agglomerative technique is initially each data point is considered as each data point. So what will happen in agglomerative hierarchical clustering technique, uh, initially each data points, okay, initially the individual data points are going to be considered as individual clusters. Okay, so if I am having 5 points, 1 2 3 4 and 5, then 1 is cluster, 2 is cluster, 3 is cluster, 4 is cluster and 5 is cluster. They are individual clusters. So this is an iterative algorithm, so it is an iterative technique actually. So at each iteration the similar characteristic data point are going to be merged with each other. Okay, so like 2 and 3 data point are having similar characteristic, then I'm going to put it in the same cluster. Okay, so in a very similar way, if my 4 and 5 are having similar characteristic, then I'm again put that 4 and 5 in the same cluster, and you will do for simultaneously for each and every clusters until one cluster or k clusters are going to be formed. Okay, this is the approach of agglomerative. So I'm going to write it down here. In this technique, initially, okay, each data point is considered as an individual cluster. Okay, as this is an iterative algorithm, so and now for each iteration, where is it, similar, I think, yeah, similar data points are merged with, actually not points but clusters, similar data points or clusters are merged with each other until cluster or m clusters are formed. Okay, this is the approach of agglomerative technique, and we will understand it more precisely in a while. So let's say the first step of this algorithm or first step of this technique, the steps you will write in your own words. I'm just going to give you that what will happen, what are the operations with this technique. So the basic algorithm, you can find, let me just write down basic steps. So the basic algorithm steps or the operation. So first step is to compute the proximity matrix. Which means that how they are correlated with each other, or how the data points are very similar to each other. They are finding the similar characteristics. So compute proximity matrix, and then assume that each data point is a cluster. Assume it, okay. And the third step is you are going to repeat it. So what you are repeating? You are merging to closest, that means similar characteristic cluster, and update proximity matrix. Okay, and next step is you will do the same thing until you will get one cluster. Last step is until a single cluster remains. So these are the 4 steps that this algorithm possesses, and we will see in a diagrammatic view. We will see each step in a very elaborated way. Okay, so let me find a suitable color for it, and then we will proceed. Okay, so initially, let's say initially I have 6 points, and this is the vector space A, B, C, D, E and F. By the way, I mean the example I had taken it from medium.com. You can also refer the resources as I told you earlier. So these are the 6 data points A, B, C, D, E, F, and the step 1, as I told you, that it will calculate proximity matrix for each point. So when I say point, that means A, B, C, D, E, F. For all these points, I need to calculate proximity matrix, um, and assume that they are not single data points, but they are 6 clusters, 6 individual cluster. Okay, so we are assuming it. So I will draw it over here, that this is A, this is B, C, D, E and F. So they are single individual clusters, and we had calculate the proximity matrix between these two things. Okay, and the next step is, so my step 2 is going to be similar clusters are going to be merged. Similar clusters are merged together and form a single cluster, So for this reason, so let's say let's go down and let's assume that here in this example, let's say B, C and D, E are similar clusters. So for this, let's say B, C, and this is my AND actually. I don't know how to draw it, but let me try. Yeah, so B, C and D, E are having similar characteristic, and I need to merge it, right? So what I can do is I will again create this A, B, C, D, E and F, and I'll change the, actually I need to go up, so I'll again going to change the color here, and what I can say here is that I'll make this cluster B and C. I put that in one cluster B and C. In the very same way, I'm going to take a D and E and I'll put them in one cluster. This is the second step. Okay, so you can understand that B and C and D and E are having similarity with the help of, we can get it from the with the help of proximity matrix, and for that reason we cluster them into one cluster B, C and D, E. Now the leftover is, so leftover here. Leftover, what is the leftover is I'm having now a set of A, then BC, then DE and F. From 6 individual clusters, I'm getting the leftover as A, cluster BC, cluster DE and F. This is the new thing. Okay, and again after this step, again what I gonna do is I'll calculate the proximity matrix again. This is my step 3, again calculate proximity matrix of new cluster, because you are getting new cluster as B, C and D, E. Okay, so you need to calculate proximity matrix for these new clusters and merge again the similar cluster. Okay, so now what we are doing is to form new clusters. So to form and merge the similar clusters and form new cluster as A, B, C and D, E, F. So that means I'm putting this F and D, E in the new form. So again I will draw this figure. So A, B, C, D, E and F. This is the earlier step, and we had joined this B and C here in this cluster, and then we also had formed a new cluster here, D. Now we are joining this DE and this F to form a new cluster here, D, E and F. Okay, are you following this? I think you are following. Now again, what is this step? Again you are forming the again you are calculating the proximity matrix for these new clusters. The cluster is A, B, C and D, E, F. The leftover is, again here I'm writing down here, leftover is going to be A, B, C and D, E, F. I'm having now 3 clusters over here. Okay, are you getting it? So A, B, C and D. Now the next thing is what I'm gonna do is I will join my BC to this DEF. What I can say is, again you will, this step 4. Okay, I'm writing here step 4, but just I'm changing this in the new color so that you will understand that yeah, I'm providing the step 4 here. Okay, so this is my BC and I'm joining it with DE. Okay, so this is your new cluster and the cluster is going to be BCDEF. Okay, so this is my step 4, and again you will, so the leftover is A and BCDEF. Can you see, we are left with 2 clusters only, and now what I want is I need to merge these 2 clusters, the leftovers A and BC. Okay, so this is A, B, C, D, E, F. This is the last clusters till this agglomerative technique is going to work. Okay, so this is the single last cluster that agglomerative technique had given you. So this is my step 5, by the way. Okay, and at the last I'll separate this out, that the last it gives you the single most cluster that we want. Okay, and you can see this cluster, this whole thing, you can visualize it with the help of technique called as dendrograph, and the steps that you had provided over here in this diagram, you can provide the same thing in the dendrograph. And how you can do that? Well, basically I'll provide you that. Take a new page and you take a line here, and this is line. You will provide some data points here. So this is my A, B, C, D, E, and this is F. So earlier what we did, we combined this B and C. Okay, actually I again have to take some new color just to make some difference. So this is my first cluster that we had seen, and we joined this DE. This is my firstmost clusters, right? And then what I did, the next step, we had seen that we have merged the D, E and F. So D, E and F, we had joined this, right? In the next step what we did, we joined the BC and DEF, right? So again I'm going here, and just take some color, and I'm joining this BCND, okay. And at the last, what we did, we joined this BCDEF with the last data point, okay. So this is the thing that we had seen. So this particular thing is known as dendrogram, okay. So this is the thing that we had seen, and I hope you understand the agglomerative technique. There is one more way you can put this diagram in dendrograph, but there are varieties of way you can look after for that, okay. So this is your dendrograph. It is a tree-like diagram that records the sequence of merges or splits that you had provided in the agglomerative hierarchical clustering technique. Now the next clustering technique is divisive hierarchical clustering technique. Well, it is not I mean, it is not worthy actually. It is not much used in the real world actually. So that's why I'll give you just an idea on divisive hierarchical clustering. It is just an opposite, exactly the opposite of agglomerative clustering technique. So I'll write it down here that. So we are there, we are merging the things. We separate the data points from the cluster which are not which are similar. Here in this divisive, we are joining the data points for the clusters which are not similar, okay. So this is the only difference between agglomerative and divisive. There we merge two data points having the similar characteristic. Here we are merging two data points, they don't have similar characteristic. So let me write it down here. So I'm talking about divisive clustering technique. And what I can say about divisive, actually this, I don't like this, okay, and I again don't like it, so it takes some time. Okay, so now I'll write here that it is exactly opposite of agglomerative technique, okay. Consider all data points as single clusters and not individual cluster. This is also difference. Single cluster, okay. We are the single clusters, and where is it? Yeah, and in each direction we separate. This is separate, by the way. We separate the data points from the clusters that are not same, okay, that are not same, just the opposite of agglomerative. Okay, so at the end, what will you get? At the end, you will get not a single cluster. At the end, you will get end of iteration you will get n clusters, not single clusters, just the opposite of agglomerative, okay. So you will get A, B, C, D, E, F, n clusters. I hope you are getting it, and you understand the divisive clustering technology, technique. Thank you so much.